All right, this should be our final installment of Notes 2-2. Right. We're to answer the following questions about this function. What is the domain of f? Okay, so the domain of our function, remember, since it's division or it's a fraction, however you want to look at it, this cannot be 0. So x plus 2 cannot equal 0, which means x cannot equal -2. Okay, I like writing it in the interval notation, -infinity to -2, union -2 to infinity. Okay. What is f of -1? So when the number's inside the parentheses, right, f of, we replace the x with what's inside the parentheses. So we have x is -1 minus 3, and then -1 plus 2. We simplify. -1 minus 3 is -4. -1 plus 2 is 1. So we get -4. Okay, what point is on the graph of f? So since x was -1, and we solved and got -4 for our y. Right? Where does f of x equal to? Okay, so f of x is this entire thing, x minus 3, x plus 2. So where is that going to be 2? Okay. All right. Again, as I said before, I like to multiply by the denominator to start with. So I get x minus 3 equals 2x plus 4. Okay. If I remove that x, it's being subtracted, so I get x. So I'm also going to want to remove this 4. So I get -7. Okay, so where does f of x equal to? At -7. Okay, name the ordered pair. All right, well, x was -7, y is 2, so -7, comma 2. Alrighty. Okay, gonna go ahead and move this up just a little bit. Try and straighten this out too. Is the point 1, -1/2 on the graph of f? Alright. I could substitute either of these back into the equation to find out if it resulted in the other number. 1 is a friendlier number, and also it's usually easier to replace x than it is to replace y when they're written in function notation. So I'm going to go ahead and do that. So x we're going to replace with 1. One minus 3 is -2. 1 plus 2 is 3. So 1 in my function produced -2/3. That's not the same thing. Okay, so is the point 1, -1/2 on the graph? No, it is not. And I know for sure, even though, maybe I could put 1 in again, some of you are thinking, and get something else out. But the thing is, they told us this is a function. So for each x, there's only one possible y value. And for 1, that y value is -2/3. Okay, so you might want to make a little note of that. Since 1, -2/3 is on the graph, okay, and no x can be repeated or can be reused, -1, 1, -1/2 is not on the graph. All right. Okay, Where would the graph of f cross the axes? Well, they're simply asking you where are the intercepts. Okay, so remember the x-intercept is of the form a0. So we're going to replace the y-coordinate in the equation. So that's going to be 0 equals x minus 3 over x plus 2. Okay, so if we multiply by x plus 2, we get 0 equals x minus 3, which means x equals 3. So the coordinate would be, it would cross at 3, 0. And at the y-axis, right, so the form b, 0 comma b, so we're going to replace this time x with 0. So we get f of x equals 0 minus 3 over 0 plus 2. So f of x, which is our y, equals negative 3 halves. Okay, so our answer here is 3, 0, and 0, negative 3 halves. Alright, so what is f of negative x? Right, so inside the parentheses, we replace our x's in our original equation, which was x minus 3 over x plus 2. We replace the x with what's inside the parentheses. Okay. So then we simplify. Negative x minus 3, negative x plus 2. I personally am not a big fan of the negatives as leading, so I'm going to factor that out, and we get negative 1 times x plus 3, and negative 1 times x minus 2. Negative 1 divided by negative 1 is 1, so my final answer is x plus 3 over x minus 2. Okay, and then what is the opposite of f of x? Okay, so we write down the original equation, and we want the opposite of it. Okay, so we distribute, and we get negative x plus 3 over x plus 2. Again, not a big fan of the leading negative. However, any factoring would not get rid of it, so I'm just going to go ahead and leave it there. So negative x plus 3 over x plus 2. Alright, that's the end of our notes. Hope you enjoyed that little lesson. Hope you guys are able to get your work done from there.